Okay, happy to see you here on our intermediate meeting. So let us start with a short introduction of ourselves. My name is Ilya Buryenko. I'm a computer vision engineer at Technical University in Dresden, Germany. I'm working on multi-model models and on different self-supervision tasks in application to communication analysis. Yeah, that's it. So I would ask to introduce himself Kostya and Ivan.
Hi, everyone. My name is Konstantin Yegorov. I am the data scientist in Sberbank AI laboratory. I am working on mainly on computer vision application in medicine, and also biosignals like ECG, EEGs, PPGs, something like that. Okay, Ivan, then next.
Can I introduce myself in the presentation?
Oh, sure. So that means that we have. So today's agenda is on the first step, Ivan will give a short, I think 30-minute presentation, right? 30,
Maybe
40,
a little bit more than 30
Okay,
minutes.
that's good. So Ivan will give a presentation and he will say what the presentation about. After that, we will introduce a new assignment, one of our two final assignments. And at the end of our meeting, we will answer your questions that you have so far. I mean, any question that you have regarding assignments or the course in general. Yeah, so feel free to ask any questions. So then let us start. Ivan, please.
Okay. Okay. Can you see my slides? Can we count BMI?
Yeah.
Okay. Let's start. So hello everyone again. Today I want to tell you about one interesting application of computer vision, or rather the calculation of body mass index. Why is this task so important, and is it even possible to calculate this measure without knowing the height and weight of a person and using only its face? First, I'll tell you a little about myself. My name is Ivan Sviridov, and I work in the Sber Artificial Intelligence Laboratory with Konstantin. And before that, I received a bachelor's degree in mathematics and computer sciences at the Bauman Moscow State Technical University. Next, I received a master's degree from the Higher School of Economics jointly with Sber. And while studying at the High School of Economics, I wrote a term paper with Ilya. And then I wrote a diploma paper with Konstantin, and that's how I met the Sber laboratory and eventually received an offer in the medicine group. And now I work in this group, and we trying to find some innovative and interesting applications of existing AI state-of-art methods, and trying to develop our own methods for applied tasks and to upgrade the existing solutions. And I want to ask you, if you have any questions during my presentations, feel free to ask the same time when you want to, because at the end, I think it may be difficult to remember what I was talking about. And also, if maybe my internet will not be really good, tell that too. I'll try to fix this, but I hope this doesn't happen. Okay, and before my story, I want to make a small disclaimer. In the next slides, I will use such words like fat, obese, or ожирение on Russian, having a sort of type of obesity, and I will use these words without any negative connotation, but simply as just a statement of a fact and a descriptive characteristic of person. Okay, so body mass index, BMI, measures body fat based on height and weight of person. It's calculated just by dividing weight in kilograms by height in meters squared. It's very simple but helpful tool for healthcare professionals and doctors to access body fat percentage and monitor weight changes of patient over time. Of course, this metric, for example, doesn't include your muscle mass, but it anyway can tell a lot of your body. And I described here, in my opinion, top 3 main reasons why BMI is a necessary metric. And first of all, of course, BMI can help to identify risk of developing some specific health problems, for example, heart disease, diabetes, mental health problems, and also it can identify some medical conditions, which is not as dangerous as some health problems, but also very important, for example, as sleep apnea and back pain. And also body mass index can help doctors and healthcare professionals to recommend appropriate diet and exercise plans based on this metric and to monitor it further. And okay, I actually can't see your questions there because I share the full screen. So Ilya and Kosti, if there will be any questions in text, you can just tell them.
Sure.
Okay. Okay, I almost forgot to bring this important plot of and degrees of how to make decisions about human body based on BMI, and this will helps us in future. You will see, and all we need to know is that the lowest, I think, value is for body mass index is approximately 18, and if your BMI value is lower than this, you are underweight, and if your value is more than 30 or 25, you are overweight and may have some degree of obesity. And as I mentioned earlier, in order to determine this body mass index, you only need to know the person's weight and height. So what can be easier, but however, not all people know and remember these indicators, these parameters, especially, for example, athletes who are rapidly changing their weight, or teenagers who are growing very quickly. So it's really hard to detect every time and remember these parameters. And also, in the other hand, telemedicine or remote examination patient by a doctor is gaining great popularity nowadays. And not everyone has a scale, for example, at home, and people with, especially people with disabilities, so they can have problems with measuring their height, for example. And if you are in the doctor's cabinet, you can just use the tools in this cabinet, but when you are working with doctor online, you may just not have this equipment. And actually, the only and the most important thing that doctor sees in this remote examination is your face. Therefore, it may be possible to develop an algorithm or model that can determine your and count your BMI index based on your photo, and this will significantly help the doctor in the further examination, conclusions during the during your examination, and make the conclusions more precisely for you. Okay, let's start with solving this problem with the first and most important, in my opinion, step, namely research. It's always important to study the works of other authors who solved the same problem or try to solve it in order to study the methods they used, the results they achieved, which hypothesis worked for authors and which did not work, and build on this basis your own thoughts and hypotheses. I put that list of papers in chronologically order, and the first, I think, some first significant work with a lot of citations is this paper from 2013 year, where authors detected on the person's face some key points and built classical machine learning models on this on these points. I think that authors used support vector machine, and they gained the they used as a loss function, they used mean square error because it's easy to differentiate, and they, as the final metric, they used mean absolute error to count their model quality on the morph2 dataset. And as I told you before, you can download this presentation. I think that Ilya and Konstantin will send it to you, and all that underlined dates and words, they are with links to this paper, so you can watch these papers by yourself, and they may be helpful for you too. The next paper was estimating the height and weight by the separate models.
Only how to determine key points on faces.
Can you repeat, please?
To do with the BMI, right?
Repeat, please.
Yeah, the first paper from 2013 has nothing to do
yeah,
with
can you repeat
BMI.
question?
Yes, I'm trying to do that. Can you hear me?
Yeah.
All right.
Yes. Paper for BMI.
Is it my lag or your lag?
I hear you, but like you're talking with some pauses.
Yeah, I'll put my question in chat.
But I can see the chat because I'm translating the one big screen.
All right, but
maybe
now
you can
you
just
hear me?
Yes.
Okay, so now the lag seems not that significant.
Yeah.
So the first paper from 2013, it's only about how to find faces key points.
No, the authors, they used some old algorithm from the, I think, 80s or 90s to find these key points on the face. They got these key points, and on the right photo, I forgot to say, they count, they made some linear combinations with these dots and count some parameters. For example, the distance between your like left and right cheeks, distance between your eyes, and they built support vector machine model on these measures.
SVM on handcrafted features. Okay.
Yeah, and they gained mean absolute error approximately 3 and 2 on the dataset, which is I think not so bad. I will tell that it's a good measure, but I will tell you later about the problem with these measures and these datasets.
Okay.
Okay, and in the next paper, which I would like to tell about from 2018, authors tried to estimate the height and the weight from the BMI by the separate models. They were approximating the height with some ResNet model, and they were approximating weight by the another ResNet model, and the output from these two models, they just get the weight and divide it by the height squared from the second model, and that's how they get BMI result. Or their height model had a little mean absolute error. I think it's close to 0, but the weight model has a big mean absolute error, I think 8. But in total, they had a mean absolute error approximately 2 and 36 on their dataset, and that's where I get the problem that the authors, they tested their models on their own datasets, which is not some, I think, qualitative study. Since a lot of depends on the data set, you may get data that is very easily separable, and you can build with some simple model, you can get a good result, but you can get the data set which is complex and noisy, and even with strong architecture, you can get bad results. And there is no
is it openly available data?
None of these data in these papers are not unfortunately publicly available.
Okay.
Yes, I got the one data set from the authors of the paper. I just emailed them directly and asked, can you provide me access to your dataset? But other 6 or 7 authors, they ignored me.
Yeah.
So yeah, and there is no the main problem that, in my opinion, that there is no publicly open benchmark on the body. Actually, everybody get results of their own, and there's actually not such a lot of data to compare with. But in the next paper from 2021, people worked with face segments. So they made a segmentation masks. They got, for example, eyebrows, eyes, nose, lips, and they sent it to the convolutional model. And also they sent the whole face to the convolutional model. They made some with these layers and the outputs, they made some nonlinear transformations, and they got the final result. And the good thing that they used this dataset, VIP attribute, from the previous paper, and they got the mean absolute error twice less than in the previous paper. So they actually improved the metric, made it smaller, and they got mean absolute error approximately 5 on other dataset, visual body to BMI. And with this data, with visual body to BMI, these authors worked with the dataset. So it's really hard, and you need to look at all these papers and compare the datasets by yourself to make a decision. Is the algorithm that authors introduced, is it actually good, or they just find a good lucky dataset? And these authors in this paper, they used pre-trained architectures. For example, they used DenseNet, and the simple but strong thing, which, for example, I didn't try to make, but I will try it in the future. They painted black ground with a black color.
Do we lost him?
Black coloring the background, and they got the worst results because the background noise.
Fine, I think that you can switch off camera
Switch off.
because the internet connection is unstable. Can I? Yeah, I think I can switch off. I switched off your camera. Ooh.
You probably switched off only for yourself because I still can see him,
Really?
but can't hear nothing.
Yeah, me neither. Okay, then I'll switch on his camera for me. Question, and do you know what are these data sets? How do authors describe how they collect data? Yeah.
Okay.
I'm sorry for the
Yeah, you can
problems.
switch off your camera.
Yeah, can you see the presentation and hear me?
Yes, the presentation. Yes.
But for me, it's saying that it seems that you're not online.
For me, it's everything good.
Oh, okay.
Can you also maybe turn off your video camera?
Okay.
So it won't affect. Okay, the question was how these data sets were collected, right?
Yeah, I mean, do you have any idea? I mean, what are these images, and how did they collect ground truth and so on? At least, do they describe this procedure?
Yes, they describe the procedure of how they collected the data, and actually, it's really I think it's really cool method, and I will tell it on this slide. Data preparing, and the most of the authors they used the Reddit platform. If for people who are not familiar with the Reddit and how it works, Reddit provides a lot of forums or subreddits when you can describe some things which you are interested in. And there is a really popular subreddit called Progress Pics, where people share their progress, how they lose weight or gain muscle mass, and almost all authors of the previous papers, they collected their dataset by using the Reddit API and getting the pictures and the BMI metrics.
Right. Could you try to stop your sharing and switch it on once again?
Okay.
Yes.
Yeah, so you can see.
Yes, now we
Okay.
can. Thank you.
So the how the authors and I collected the dataset. They used, as I described, the Progress Pics subreddit from the Reddit platform. And the good thing about this subreddit is that people, as you can see on the picture on the right, they write a post and they write their height and weight changes, and they attach the photos before and after. So using this title of this post, they are written in the same way, so you can use regular expressions to parse the weight and height and count the BMI. And you can use the face detector model to get the face from this post. And actually, you get what you want, and you collect the faces and the corresponding BMI from this subreddit. And first part of my dataset is face in the wild for BMI dataset from the 2019 paper. This paper is not such a like some state-of-the-art work. Just they introduced this big dataset with 8,000 face images, and I decided to create my own dataset using the same techniques as the authors used. But the main problem is that Reddit has reduced the capabilities of their API because they do not want to train large, they do not want to other companies to train their language models on their platform. So they made it possible only to receive latest 1,000 posts. Without any data slices, so you just can get like 1,000 previous posts, and that's all. So I wrote an algorithm that every day in the evening it takes the newest photos from the subreddit and adds them to the existing data, so dataset is constantly updated and expanded. And I detect faces using the YOLO model, which you can if you want to see with this link. This model is, I think, the state of art on the face detection, and it detects faces pretty good, but I think it has low precision because it detects people with the smartphones. For example, if someone is taking a photo like this, the model will detect face, but it will cover it on the phone. And also this model detects the images because some people don't want to share their faces, and they cover it with images, and the model detects images too. And I have questions about, is it ethical or legal to use this kind of data collecting? And maybe I don't know, what is your opinion about that? But authors, they published their works on the top conferences and the journals of Kuban, and I think that if this committee of these journals and conferences approve this paper, so maybe it's okay to get data this way.
Well, I don't see a problem here. Once they're publishing their own photos on the internet and on Reddit, so what's problem?
Maybe, but I think that maybe if this model will will be in commercial using, there may be questions. But I think that this.
We'll see how OpenAI will get rid of this claims that they're using copyrighted stuff.
Oh yes, we'll see. But that's how I got the faces. And
we have a question. I'm sorry for interrupting. We have a question from Alexander, but I'm not sure that I've followed that question. So what do you mean by receive the explicit consent?
Yeah, I just meant you were talking about the ethical side of the question, and I was wondering if they just received an explicit consent of people that they're capturing or they're trying photos of which they're trying to analyze, because as I understand, some medical trials, there's a group of people who are going through the trial is usually signing some papers that I can try experimental drugs, and I think the same is the case here. Probably these people just signed that their photos can be used in the dataset.
I don't think that's true. Just for every 8,000 people, random people from Reddit to.
It should be Reddit's policy. But everything that is published is publicly available.
I also try to generate the faces using the Kandinsky, but this was like for fun, and it actually generated some good faces, but I didn't use them. And I found
Oh, I like that one.
I found on the Kaggle a dataset which contains almost 60,000 photos, and they are mugshots. And this dataset is only with 2 upvotes. It's also available with this link. And this is really strange because every BMI dataset is very popular if someone announces it, and this dataset has only like 2 likes. But this dataset have a lot of people with different races, and to reduce bias and variance, I used the model from our colleague Andrei Savchenko, who made a SOTA model to detect race. And I selected only European people just to try how this BMI model will work only on some subsample of popularity. And after filters, I got approximately 20,000 faces. So my training dataset, train, validation, and test dataset was approximately 35,000 faces. Next, I tried to make my own architecture, and I worked with. Firstly, I worked with faces as standard RGB tensors, red, green, blue tensors with 3 channels. And firstly, I used standard some linear and ReLU sequences. So I passed the image to the linear, and after the non-linear transformation, and got the. I was solving the regression task, and finally I got the 1 output value. After that, I used convolutional and ReLU sequences, which are basically also linear and ReLU sequences, but with a convolution. And I added to this model this possibility of batch normalization. So you can in this architecture turn batch normalization on and off. And I used residual networks, some standard residual models, because they are showing good results in many tasks. And all the parameters which I experimented with, they are on this screenshot on the right. There are all basic parameters, and I use transform Boolean feature, which made some augmentations to the face, for example, brightness changes, some rotations, zoom, and I also experimented with loss function. I used not only root mean square error, but the Huber loss, which can which deals with outliers, and it's Huber loss. It doesn't make a big loss for the outliers. So maybe I thought this can help model to work better with this data. And I selected the best model using the RayTune library. This is basically random search, and this library is very, very cool. You can tell how many samples you would like to, how many model configurations you would like to sample, and this library will sample the parameters from your parameter space and select the best model. For example, they can stop the worst architecture and not to continue it till the end of your number of epochs. And I face the problem. Yeah.
Sorry, may I ask some question here? Yeah, just wonder if the RayTune library is greater than the popular Optuna library, or maybe you have used both of them and stay with RayTune, or you just It was your first choice to use the
Uh,
RayTune.
Okay,
What
I
do you
think
know?
that I just Googled random hyperparameter search, and I got the RayTune result. Also, my colleague was using RayTune library with his models, and I decided to just use RayTune. And I didn't work with Optuna, but I know that it's also very. But like I just decided without any arguments to use the RayTune and work with it. But maybe it's maybe good experiment to use Optuna.
Okay.
Yeah.
Yeah,
And
thank you.
so I just got the problem after I started training, because although the value of the last function it decreased, and the validation metric was not so big, approximately 5 mean absolute error in the inference on the photos. I tried my photos and photos of my colleagues. The model hallucinated and produced some values from 0 to 50, and I made the slides with the BMI types, as you can remember that the values exist, for example, from 18 and to 30, but there can be values like 0 or 50, because they are outliers, and the model was working awful on the inference data. And I decided to look at the training data, and I realized that this big Maqshot dataset, which comprised almost 60% of the entire data, it had many abnormal values. As you can see in this data example, there are a lot of very bright photos, and there are also a lot of abnormally BMI values. So this dataset is very noisy. And I decided just to remove this dataset, and everything worked. Everything started to work. So maybe if you find some treasure, you can think that you find a good dataset with a lot of faces. You train your model, you validate it on this dataset, because the test and validations, please, they came from the same data. But if you want to decide to show your model to other people on their faces, this will fail. So it's important to validate your model not only on the dataset. So I decided to remove the Maqshots, and results improved, and I came with the result. As you can see on this plot, it's the validation root mean square error, and the RayTune, it starts to train all the models, and after some steps, it stops the worst models and continues to train the best ones, and after some steps it selects the best model. And I tried a lot of different configurations. I ran these models a lot of times, and after some trial I saw that the less learning rate is better, so I decided to decrease learning rate, and therefore finally I came that model with this configuration, this learning rate, residual network, without any transforms, without any batch normalization. It works with the mean absolute error 3 and 8 on validation, and approximately 4 and 7 on testing. Okay, I got.
What was state of the art mean error previously? It was something like 2 units, right?
Can you repeat, please? My internet connection.
Yeah, what was the previous state of the art mean error?
Previous state of the art result, I think, is on these papers, which are, for example, 1 or, but on the most papers, people are fighting for the, for example, previous state-of-art method was 3 and 14, and we got 3 and 12, so we are better now. But I think this VIP attribute dataset,
they have very different data compared to yours. That's true.
Yeah, and these datasets, they are small. I think that VIP attribute is maybe 600 photos, and here's the problem with the public benchmark doesn't exist, and you can compare your results with some existing results, but authors of this paper, which dataset Face in the Wild for BMI I used, I think they got a result on the test closer to 3 and 5 or 3 and 3. So on the these results I got, it's worse than their results, but they are like at this point when I was on the step, I thought like, okay, good result. I will try some more architectures.
I would like to say that you have 5 minutes left.
Seriously? Okay. Okay. After that, I decided to work not with photos, but with embeddings. And I thought that this multidimensional representation may be better for the model to dive in and find some optimal hyperparameters. And I think you can choose whatever you want to use as embeddings. And I decided to use the output from the YOLO model, which detects faces. I used the last convolutional layer as the embedding, and I just fed that representations into the classifier. As in the previous case, I used also convolutions. I used some linear layers and residual networks, and I got the mean epsilon error 4 and 1, which is worse than in the previous case. But on the test, I got the best and better result in the previous case. Even though the model performed worse during validation, the final metric improved during testing. And as we can see, on the embeddings, even the convolutional network works very well, and with the Huber laws. So these parameters like slightly different that in the previous hypothesis. And final one, I tried to use the facial key points of the face or face alignments. As you can see on this GIF I made, these are the key points of the face as the authors from the 2013 year paper used, as I described at the start of my speech. And they just get these key points of the face. They got with the library, MediaPipe library from the Google. They collect from each face 468 points, two-dimensional, and I just fed these points to the just XGBoost regressor to find how can this information and this model perform on their faces without any channels and deeper understanding, just key face features. And also I wrote that in this way they are not noisy information, for example, clothing, background, it can perform better. And I chose hyperparameters with RayTune also, and I got the best test results along all three hypotheses as I researched before. But I must repeat that these results were only on the test dataset which were created from the data. I decided to inference it on the real people, and I found some trends in the Instagram where people share their weight progress, and I made a model. I hope that you see the video. It didn't start yet. I hope it
I
starts.
see it's running circle.
It's very slow. Oh, can you see it?
Yeah, now it's working. Yeah.
So as you can see, in this video, people share
The same
their
person?
and this was the picture video before and after, and I detected the face with the as you can see with this rectangular and BMI count on the left top corner, and as you can see the model which is the convolutional model from the just faces. I plotted this video. I just plotted it in this way. On the x-axis the frame number, and on the y-axis there's the BMI number. And as you can see, at the start of the video, model counts BMI is some people like with overweight, and then it dropped as it's. But I don't know the BMI characteristics of this person, so I can't precisely tell the value. But that fact that model drops the BMI after drop in the video, I think it's a good sign that model can describe BMI from the fat person, from it like can it like can understand how BMI changes. And after that, I tried to work with the boosting model, and which has the better metrics on the test. But on the video, as you can see, it actually didn't catch the difference between persons' BMI change. I think it's very noisy, and at the end, it said that the person has even bigger BMI than they had before, and this is, of course, not true. And they think that even this model performed better in the test. It in the
Maybe you try to pick an example.
pick another example.
No, I mean that, but I mean it's strange that I mean you have two models. They have more or less similar results on test data, right? Because one has something like 4.2, another has something like 4.1 error rate. But I mean, maybe this example that you are showing to us is cherry picked. So one model is doing good, while another model is doing bad.
Yes, I had another, I think 6 or 7 videos I chose from the Instagram, and on all that videos, the convolutional model showed bad results, and boosting model performed quite poorly. And I think that this is maybe because just the convolutional model, it sees like picture on with all 3 channels, and model see this like face square, and boosting model sees only face points, and maybe it's worse than the seeing the whole picture, and maybe in this particular data set, this XGBoost configuration showed it better, but this is not true in the real life. I don't know, but this is very interesting thing.
I'm not satisfied with this explanation, but yeah, I think the reason is different. But yeah, nevertheless, okay, wrap up, please. What conclusions do you have?
Okay, some final thoughts. In my opinion, I think that first of all, it's really important to make good research to understand state of your task you want to solve, which existing methods were tested, which results they got, and what methods can be improved and, for example, used as baseline. Also, it's very important to explore hyperparameters. I didn't want to take more time from you, so I just want to say that I tried a lot of hyperparameters in the rating model, and I see that, for example, on the RGB phases, it's important to use less learning rate, and for boosting, it's important to use smaller tree depth. So you should see all these hyperparameters and decide how the particular value can be important for your task. Also, it's important to recall that simple architecture can produce results comparable or even better than the complex pipeline, as we saw in the comparison with boosting and convolutional and residual networks. And finally, that if there is no publicly available benchmarks, you shouldn't trust this perfect metrics from the explored articles. Maybe they're really that good as the authors describe, but we never know how this model works on the real live data. And you should test all your trained and selected models and the results in the real life to see maybe your model in your dataset performs good, and on the video or photos or from the real life, it can hallucinate. Yeah, so I think that's all. And
thank you very much.
Critics
I
and
love the talk very much. Yes, question, please.
And some critics I will be pleasant to.
You know, I have no critics, but can you switch please to the slide where you have the video with that woman? Yeah. Maybe I'm hallucinating here, but when you turn on the video, it seemed to me that it's just the area of cheeks and chin is just fake one. I don't know why, but maybe through the presentation, it seemed like it's not real, not live, just maybe some app. I don't know. And so
interesting.
Just
I think it's just compression algorithms. I mean, I agree with you. I see the same, but I think it's how this video is compressed. And it's compressed the second time for that presentation, and then via this webinar.ru. So, yeah.
Yeah, maybe it's not true, but just the question is, if it is fake, so is it reasonable to use such videos for testing or not? Or we will have some false positive or false negative results? I don't know. So just how relevant such videos, if we consider that it is fake one, just the bottom part of the face. So is it relevant to use it for testing, or it's like a synthetic data and we just couldn't do this?
Yes, I think that
like that.
Even if this video is fake, I think it's important to test your model on this kind of data, because we can see that the person in the start of the video, she has obviously BMI much more than in the second part of this video. And if model tracks that difference, is good, because, for example, the boosting model, it didn't track even this change. Even if this was a fake video, it didn't track it. So I think it's even worse than if it was a real person. But maybe this is a fake video. But my point was in that you must test your model on the kind of this real data.
Yeah, thank you. This was just my curiosity, so I just
Other questions, please.
wondered.
Really?
There is one in the chat.
It's not actually the question. I just, yeah, I was going to ask the same question. If you thought about using some video games like, I don't know, Sims or Fallout or, Starfield, because the character editor has, I think, even similar parameter like BMI or something. I don't remember exactly, but you can do it faster,
Maybe yes. I think it's a good method to try the model, and I will write it to try in the future, because yeah, it's interesting to. I think it's actually interesting to test your model on any data just to see how it works, and can it even like approximate the BMI. So I think all methods are good. But in the research papers, of course, like you should use the data set which you are sure that is correct. But I think that with the development of neural networks and these deepfakes stuff, I think it's hard to say which is real and which is not.
More questions? Okay, then I would like to add some comments. I must say that I really, really liked the presentation and the whole work pipeline, the whole workflow. So I find the data collection process so cool because, I mean, that Reddit thread and this mugshot data set, I mean, I like it very much. That's really ingenious, I would say. So I would like to underline several principal points in that workflow. So Ivan started with an idea of what he would like to do. After that, he tried to collect data, and that part was genius. After that, he implemented his algorithms, and he did some hyperparameter optimization. Yeah, there was a tedious and maybe not very exciting trial and error part when you try to find the best hyperparameter set and so on. But I mean, that's everyday life of deep learning engineers, so you can't complain really here. And what I would like to say more is about, I really appreciate that you did data cleaning. So you realize that I'm not sure that the best way to tackle this problem, but at least you notice that you don't achieve good results, and maybe that's because due to not the best data. After that, you cleaned your data. That was a very good idea. And also, I think that's how you check that how you check that your different models. I mean, your deep neural network, your ResNet, and how you compare it to XGBoost. I also find very interesting and very helpful to see that. I mean, raw numbers. When we're talking about applications, raw numbers can lie to us. That's why I agree that yes, it's very important to see what you have as output in your real life application. That's why also I like that idea with Instagram threads. So Vanya and data, that's perfect match. So thank you very much again. Now I think that you can switch off your presentation, and we'll proceed to the next assignment that we would like to announce to give you today. Let me. Yes. So we would like to ask you to do something similar to what Ivan have presented to us. Because actually, as what you saw is a quite usual workflow of what people do when they're trying to build an application and real world something that has application to real world problems. So for that, we would ask you to, let's say, so for example, you can start with a problem that you would like to solve. So in Ivan's case, that was, let us try to determine BMI based on faces. So you could start with a problem, and after that, you need to realize what technology do you need to use in order to solve this problem. So in Ivan's case, that was something like a regression problem. So you have an image as an input, and you would like to predict a number with a BMI as an output. But I mean, it's up to you what problem that you choose. So based on that problem, you choose a technology, and after that, what we would like to ask you to do. Let me share my screen. Yes, window. So probably you see, which window do you see? I'm curious.
Now it's Ivan's presentation.
This one. So now you see the new tab, right?
No, we see Google Docs.
You see Google Docs. You see. So you're here now. You see, yeah. So we would like to ask you to go to huggingface.co. You go to models. I'm clicking on presentation. You go to models, and here in models you have different technologies. Let's say depth estimation, image to image, zero shot classification, and so on. So let's say that Kosti and I, we had an idea. For example, we are bird watchers, and we would like to build an application which will classify us birds. So we go to that's why since we want an image classifier, we go to image classification. Here you can sort them based on trending, most likes, blah, blah, blah. So let's take the most trending ones. So I see that the most trending one is VIT base. So I go here. And usually in that model card, you have a link to a paper and some code that helps you to run this particular model with maybe some pre-processing steps. Yes, how you need to prepare your data, pre-process your data in order to give it to a model as an input. So what we would like ask you to do is to prepare a short presentation in which you will describe this thought process. So, for example, you describe that I decided to solve this problem. Based on this problem, I need to choose this technology. Based on this technology, I decided to choose this particular paper. Please read that paper. Read that paper and explain the milestones from it. What is the paper about? You don't need to go to great details. If you don't understand everything, that's not a problem. And yes, by the way, feel free to ask us on chat any questions, but try to understand maybe the most important parts of the paper. Maybe they're in method usually. So in your presentation, please explain us what this neural network does. And please try run some example in order to show us that you were able to run that particular model and you were able to, let's say, to classify this particular image. You don't need to base your presentation on a problem that I did in an example that I gave. You can start, for example, with the technology. So you say that, for example, I am interested in, I don't know, visual zero-shot image classification. So again, I go to the most popular models, I choose clip, and then I give a presentation on clip. I'm explaining what that clip is about, how does it work, and so on. And after that, I'm trying to think, to come up with an idea of my application. Yeah, so that's it. So basically, what your presentation should include. Where's my? Can you see my Visual Studio Code or not?
No.
Good. So stop sharing. Okay, let's share entire screen. Screen 2. So what we would like to have from you is the description of a technology. So how does this technology work? A working code example and an idea of an
I'm sorry. Can you please somehow enlarge the text so it will take more place? Yeah, something like that.
Is it enough?
Okay. Yeah, I think that's enough.
Okay, good. So these are 3 main bullets that we would like to see from your presentation. I mean, I'll put that everything on our chat, or maybe I'll put it on our forum. So yeah, you'll have, I'll put detailed explanation of what we're expecting from you. Here we have some, we took some, maybe the most popular models for each technology. So you have Vision Transformer for image classification, Instruct Pixel to Pixel for image to image, Video MAE for video classification. You could choose YOLO, either YOLO or DATR for object detection. One is transformer-based approach, another is, let's say, classical deep learning. You have DPT from Intel for depth estimation, and so on and so on. So it's up to you to choose either technology or a problem and to describe it. Do you have any questions regarding this assignment?
Is it the 4th-week assignment or final intermediate?
It's, yeah, it's for the, so we will evaluate it at the end of our course. So I think maybe when we'll finish, maybe somewhere around 20th of October, something like that.
When is it supposed to have a presentation or some demonstration?
Right. So we have, so it's here. We have, we decided. So right now we decided to have it on the 23rd of October. So you have only exactly 1 month for that.
Should we, yeah, and about the, should we just take the technology, use it somehow, and then demonstrate? I'm just not clear about the application of the technology. Is it like any, I don't know, yeah.
Application, yeah, application is so we would like to ask you to think how this technology might be applicable in a real world. So let's say that you know nothing about, let's say, zero-shot image classification, yeah, for example, or visual question answering. So you choose a technology that is of interest to you, let's say CLIP, and you read this paper and you run a code. And after that, you're trying to come up with an idea of an application where you could use that clip.
Should we implement this app or just
no,
tell about it?
No, just to, yeah, you don't need to implement this application.
I think a couple of examples in Jupyter Notebook or Google Colab, something like that, just to show us that this method is working, this model is working somehow.
Yeah.
So yeah, so something like the video from Ivan, from Instagram. Just a couple examples in some notebook.
That makes sense. Thank you. And should we research some ideas that we're not familiar with? Like, you said that ideas for presentation should be something that we don't know.
No, it's up to you. So, well, I mean, we encourage you to choose something new, but I mean, we don't know your background, so that's why we want to check it.
Thank you.
Yeah, does it answer your question?
Basically, anything you find interesting for yourself.
Yeah. Please ask my questions. If it's not clear at the moment what to do, or I don't know, any questions.
And maybe
10 minutes
some
long.
requirements to the presentation.
Yeah.
It's just
yeah.
length,
By the way,
10 minutes.
Of course,
Yeah.
we had an idea, so
Okay.
we want to allow them to collaborate. Do we want to do that?
Well, yes, optionally, if some of you want to make groups, so it can be a group assignment, but it's totally optional.
Yeah, we'll think about how to put that formally, because well, we don't want to, I mean, for the whole group, the whole 8 people to read one paper and running the same 12 lines of code. We'll think how to put it formally. So yeah.
Okay, so my exclusive question, should I have the web camera for this?
As long as you can share your screen, you're good.
Okay, thank you. But I promised, so I will have it.
Yes, so that means that we're somehow go to the last part of our agenda, so answering questions. Again, if you have some questions about the last assignment, or maybe previous assignments, or any other questions regarding the course, please ask them. We would be happy to answer them.
Also, on the presentation, I have a question about the usage of some methods or technologies. May I use something that is used now just for some generative technologies, models, or something like this?
I mean, the only
Okay,
requirement that we have is please use something that is related to computer vision, because that's what our course is about. So, but it's not. It shouldn't be restricted at only vision. So, if you have, I mean, for example, you could do something with visual question answering. So you could combine different modalities. Yeah, but please, one of them should be vision related modality, video or images.
Okay, and maybe some sort of deep question on this theme. If we're talking about, for example, BERT's classifier, and just using the audio, but when I'm using the audio, I just using spectrograms. So I use computer vision technologies.
I would say yes.
Is it okay
Yes.
for such sort of things?
To be honest, I believe even the raw audio signal
great,
is
thank you.
also can be okay, because it's, well, it can be processed with computer vision techniques, with convolutional neural network, with transformers. It's
Absolutely.
virtually the same.
Yeah, that's what just my sort of interest, to work with audio, like in type of spectrograms, just for that.
Okay. Any other questions?
Yeah, now I see that we still, I think, or maybe I'm wrong, for the 4th week, I see that on the platform we have some sort of maybe bug, or I don't know what it is. So I see part 4 and then part 11
that's,
lecture. So is it okay, or we
Okay,
missed something?
I've remake one of the videos. This is about
With the students, right?
with debugging.
No, it's not a bug because it's hidden from students. So we have parts from
Yeah.
parts 5 from 5 to 10 are hidden. Yes.
Yeah. Yes. So we're
Oh,
remaking
sorry.
this video. We already recorded videos. They now are on a montage. I believe in a couple of days, maybe early next week, we will release them. There will be one topic about debugging. Probably one video about 20-minute length.
Oh, okay. Thank you.
No, you're
Just,
right, because
maybe I'm
yes,
hurrying up some,
week 4 is
some
starting.
sort of.
So.
And the deadlines are not ready, I believe. For
Yeah,
week 4
deadlines, yes, we will set them, but yes, maybe not today, maybe tomorrow. I mean, at least I will have time tomorrow, not today.
Okay, I just honestly want to thank you for this course. I have already gained a lot of from this, starting from the curiosity and some interest from the tasks, to some gaps. Previously, I worked with some models and made some computer vision projects, but you covered some points that now I see I had some gaps in it, and now for now it's closed, just for these assignments that we have already. So thank you very much.
Thank you for your kind
really
words.
Great. I hope it
but
would be better.
I would like
even.
to. I mean, if you're really interested in how, how development process looks like. I mean, you need to download Ivan's presentation and go through it one more time, because it reflects the real procedure very, very close to truth.
Yeah,
Well,
it's
it's
just
not
pure
research, I would say,
researchers
because,
pipeline workflow, and it's
now it's now it's application.
it's a dream of every researcher to have some sort of implementation of his or her work.
Okay, guys.
There is a question about, can we post the presentation in Telegram chat?
Yes, we'll put that on Telegram chat and on forum as well. So no problem with that.
Okay, so we have at the end of the presentation, I remember we have the Telegram of Ivan. So I suppose we just, if we have some questions,
okay,
we could.
I think I'll stop recording.